Hi everybody, Mrs. Danielson here, and now we're going to talk about actually using the unit circle, actual applications. Why do we even have the unit circle and why do we care? So let's talk about what we will use the unit circle for, and actually there's lots of applications and reasons we have the unit circle to use. The main reason is when we want an actual exact answer for some of our applications of our trig functions. We don't want to plug it in a calculator and get out an approximation, but we want an exact value for some of our trig functions, and that's when we'll mostly use our unit circle. But there are several different applications or questions we may encounter as we go through pre-calculus where you'll need to use your your unit circle. So let's go ahead and take a look at our unit circle here. Again, remember the radius of our unit circle is 1, right? So 1 is our radius. Okay, so the equation for a circle, again, remembering is x squared plus y squared equals r squared, but our radius here is 1, so r squared is actually 1. X squared plus y squared equals 1 would be the equation for a unit circle. So let's say we're asked to come up with a point that is on the unit circle. So a point that's somewhere on, let's go ahead and change the color here so it stands out, but a point that's somewhere on the unit circle. And we want to figure out what that coordinate is that's on that point. So let's say we're given one of the points, one of the x or the y's. Let's say our point is square root of 3 over 2. So we know the x coordinate, but let's say we don't know the y coordinate, and we're told that it is in quadrant 4. Okay, so we have a point in quadrant 4. It's on the unit circle, but I don't know the y coordinate. Well, I can figure that out by using the fact that the equation for the unit circle is x squared plus y squared equals 1. What I can do is I can plug in the square root of 3 over 2 in there for x, and I get the square root of 3 over 2 squared plus y squared equals 1. If I square the square root of 3 over 2, I get 3 over 4 plus y squared equals 1. Subtract 3/4 from each side, and you get y squared equals 1/4. Square root both sides, and y would be plus or minus the square root of 1/4, and that's y is plus or minus 1/2. Now, two different options there for y, but remember the coordinate here we're looking for is in quadrant 4, and in quadrant 4, y is negative. So really the only one we're really interested in there is the negative version of y. So that means our point is going to be the square root of 3 over 2 and negative 1/2. That's the point in quadrant 4 that's on the unit circle that has an x coordinate of the square root of 3 over 2. All right, so there's one way we could use our unit circle to come up with a coordinate that has a radius of 1, right, and that is on the unit circle, kind of nifty. Now let's take some of our trig functions, and let's start working with our trig functions on the unit circle. First, let's start by looking at our basic trig functions, what we knew from the beginning, right? And that's that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent was adjacent. Adjacent, let's fix that right there. Adjacent over opposite. Oops. Opposite over adjacent, TOA. There we go. SOHCAHTOA. Right, then we had cosecant, which is the reciprocal of sine. Secant, reciprocal of cosine. And cotangent, which is the reciprocal of tangent. And then you may remember that we took those trig functions and then we shifted those into the coordinate plane. And we said opposite our angle, we have our angle right here. Opposite our angle is the y, and adjacent to our angle is the x. So we replaced our different sides with x's and y's, and the hypotenuse we replaced with an r. Okay, so we did that in an earlier lesson. So what we're going to do is we're just going to replace opposite with y, hypotenuse with r. Okay, just switching this into a coordinate plane here. Adjacent again is x, hypotenuse is r. Okay, so this would be y over x. Cosecant is the reciprocal of sine. Secant would then be x over, r over x. Let's see. I left a c out there. Secant, r over x, and cotangent, x over y. All right, so far so good. Now, we're specifically working with the unit circle here. And in the unit circle, our radius is 1. So what I can do is I can go through and kind of simplify these even a little bit more by making my radius 1. So that means, let's bunch these together a little bit. So that means that my sine is now y over 1. So I can just make my sine y. And my cosine is now x over 1. So I can make that x, right? Simpler than ever. Tangent stays the same. There's no r in tangent. Okay, cosecant is now going to be 1 over y. Secant, 1 over x. And cotangent is the same. All right. So now we have, on the bottom there, our 6 trig functions in the unit circle, right? So just in relationships to our x and our y coordinates. Okay. All right. So if we're told that, say, we have a point that intersects the unit circle at a certain point, let's say 20 over 29 and 21 over 29. What is the cotangent at that angle? Right, so we know it's on the unit circle. It has a terminal point on the unit circle. What angle meets that line with that terminal point? Well, that's the x and that's the y they've been given to us. So we can just plug that in. Cotangent we have right up above there. All right. We have cotangent right here. It's x over y. Okay, so x they've given us is 20 over 29. And y is 21 over 29. Okay, so 20 over 29 divided by 21 over 29 is going to be the same thing as 20 over 29 times 29 over 21, which simplifies to 20 to 20 over 21. And there's your answer. Let's do one more of those. Okay, let's say we're told that the point that intersects the unit circle at, let's see, let's pick -12/13 and -5/13 this time. And let's say what is the, let's use cosecant this time for that point. Okay, so cosecant is 1/y. Okay, so that's 1/5/13, which is -13/5. All right. Okay, so the next thing we need to just talk about here is that when you look at these functions, notice that some of them have x's and y's in the denominator. So what that means is there's some values for x or y that if we put a 0 in, then you're going to get some undefined trig functions. For instance, let's talk about the tangent of 90 degrees. Okay, so tangent is y/x. Let's take a look at my unit circle. I'm going to come back up here to 90 degrees. Okay, so at 90 degrees, my x is 0 and my y is 1. Okay, we come back down here. My x is 0 and my y is 1. That gives me 1/0, and that's undefined. So the tangent of 90 degrees is undefined. Okay, so there are several different places where, for different values, we do get some undefined answers. Let's try another one. Let's try cosecant of 0 degrees. Okay, cosecant is 1/y. Okay, so let's come back up to our unit circle and take a look at 0 degrees. Okay, so this time we're looking at 0. Okay, at 0 degrees, our x is 1 and our y is 0. Okay, our y is 0. So that's undefined. Cosecant at 0 degrees is undefined. There's no answer. Okay, you can't have a 0 in the denominator. Okay, so these undefined values tend to occur at 0 degrees, 90 degrees, 180, 270, right? Where we either have a 0 for the x or the y, we get some undefined trig functions. All right, so just something to keep an eye on. They do happen, okay, when you have an x or y in the denominator. Okay, let's say we want to find all 6 trig functions for pi/3. Just pick a value here. Okay, we're going to find all 3 trig functions for pi/3. So I'm going to come up here to my unit circle, and I'm interested in pi/3 this time. Okay, so pi/3, here's my values. Okay, my terminal point for pi/3, x is 1/2, and y is the square root of 3/2. Okay, 1/2 and the square root of 3/2. Okay, x is 1/2, and y is the square root of 3/2. Okay, so now I can just look at my different trig functions. Okay, sine, and we've talked about these right up here. Sine is y, which is the square root of 3 over 2. So the sine of pi over 3 is square root of 3 over 2, just like that. And what about cosine? Okay, cosine, again, from right up here, we see cosine is equal to the x value, which is 1/2. Okay, how about tangent? All right, tangent up here I have is y over x. Y is the square root of 3 over 2. X is 1/2. So the square root of 3 divided by 2 divided by 1/2. And that simplifies to the square root of 3. So the tangent of pi over 3, or 60 degrees, is the square root of 3. Okay, how about cosecant of pi over 3? Okay, cosecant is 1 over y. 1 over y. Okay, so 1 over the square root of 3 over 2. That simplifies to 2 square root of 3. Right, we can't leave that. Got to take care of that by multiplying top and bottom by the square root of 3. And that gives me 2 square root of 3 over 3. What about the secant? Right, that's going to be the reciprocal of cosine, 1 over x. And I have x right up there, it's 1/2. So it's 1 over 1/2, or 2. Feel free to pause the video, take a breath, catch up on what I'm doing, right? I'm moving through these pretty fast, so it's okay if you need to slow down for a minute, right? Cotangent is the reciprocal of tangent. It's x divided by y. And x is 1/2, and y is the square root of 3 divided by 2. Okay, so 1/2 divided by the square root of 3 divided by 2. Well, the 2's cancel, and it gives me 1 divided by the square root of 3. Okay, so we got to get rid of that root in the bottom. And I get the square root of 3 over 3. And that is the cotangent. Okay, so that's how you get all 6 trig functions for an angle on the unit circle, right? First you find the x and the y value from the unit circle, and then you plug them in using these x and y values right here. Okay, let's say you just needed to find 1. That was kind of a lot of work finding all 6. Let's say you just needed to find 1. Let's find cosine 5 pi over 4. That'll be easier, just finding one thing. Okay, so first I need to find the x and y values, the terminal point for 5 pi over 4. Okay, so we come back up to my unit circle and find 5 pi over 4. All right, 5 pi over 4. Where is 5 pi over 4? It's down here in quadrant 3. And the x and y coordinates are negative square root of 2 over 2 and negative square root of 2 over 2. All right, so let's come down here and we'll write that down. Okay, so negative square root of 2 over 2, negative square root of 2 over 2. Those are my coordinates of 5 pi over 4. Okay, I want to know the cosine for that terminal point. Cosine is the x value. So that means that my answer is the x value, or negative square root of 2 over 2, just like that. Now that's the exact value, okay? That's the reason we want to use the unit circle, because it gave me the exact value. I could, in fact, use my calculator. I could use my calculator and plug in 5 pi over 4, and I could use that in radians, or I could put that in degrees. and then get the cosine. And what's going to happen is it's going to give me a decimal approximation of the square root of 2 over 2. Okay, but this is the way you would have to do it to get the exact answer, the square root of 2 over 2, using our unit circle and not a decimal approximation, which is what you get on the calculator. Okay, let's do one more. Let's do sine of 11 pi over 6. And again, I don't want a decimal approximation from the calculator. I want an exact answer. Okay, then I would first get the terminal point for my unit circle. Okay, so I go up to my unit circle. Okay, and I have to find 11 pi over 6. Okay, where is 11 pi over 6? Oh, it's over here in quadrant 4. Okay, and it looks like the coordinates for 11 pi over 6 are 3 pi over 2 and -1/2. 3 pi over 2 and -1/2. All right. 3 over 2 and -1/2. Okay. Now we want to know the sign of that point. And sine, remember, is the y coordinate, right? And the y coordinate is the -1/2. So that means our answer is -1/2, just like that. Okay, not too bad. Actually, when you get down to it, you're just pulling the coordinates off the unit circle, and then you're just using these handy hints right here to know which, the x or the y or the combination you use to find the trig function. And that's it. You're using your unit circle to find your 6 trig functions. Thanks, everybody, and good luck using your unit circle.